This lecture, which is the second one in particle physics, will be on natural units. The previous lecture, the first one in the series of particle physics, was on high energy interaction. Now the essence of the previous lecture, lecture P1a, was that we require high energy to describe particle physics. We emphasized that to uncover the laws of nature, that is, to explore into the mysteries of the universe, we need high energy interactions, during which many elementary particles might be created that are normally not present. As was emphasized, particle physics is the study of particles. In the previous lecture, we used certain formulae. For instance, the Broglie relation was used, which is P equal to h by lambda, and some special theory relativity relation, namely equal to mc square, and this one E square equal to P square C square plus m0 square C to the power 4 were used. We note that in particle physics, we will be using quantum mechanical results as well as results of special theory of relativity. So, in other words, it will be a bit of relativistic quantum mechanics. Let us quote two basic relations, one of quantum mechanics and the other one of special theory of relativity. In quantum mechanics, there is a famous relation which is called Heisenberg's uncertainty principle, according to which the uncertainty in x, where x is position, and the uncertainty in momentum, denoted by delta p, these two quantities are related as written over there. Delta x into delta p is greater than or equal to h cross by 2. Here h cross is h by 2 pi, where h is Planck's constant of this value, 6.626 into 10 raised to the power minus 34, the unit being joule second. And h cross, that is h by 2 pi, is also referred to as Dirac's constant or reduced Planck's constant. And if we put down the values, it is, if h is divided by 2 pi, we end up with this value. It is 1.55, that is, if we approximate, we get 1.06 into 10 raised to the power minus 34 joule second. The other relation which special theory relativity says is that c is constant, where c is speed of light in free space and the value of c is 3 into 10 raised to the power 8 meter per second. And this result is actually called the second postulate of special theory of relativity. Now, what message do we get from these two famous or fundamental relations, one from quantum mechanics, the other one from special theory of relativity? Let us first consider this relation, which says that the product of the lack of precision or uncertainty in x and in p is as big as or even bigger than h cross by 2. So the uncertainties in x and uncertainty in p cannot be arbitrary. If one is infinitely precise, the other one becomes infinitely uncertain. So it is clear that this h cross sets a limit to all. On the other hand, in this situation, special theory of relativity says that c is constant, which means No object or signal, whatever, can move with a speed that exceeds the speed of light in free space. All objects in nature are constrained by this speed of light. So movement with arbitrary speed is not possible. C therefore sets a limit to all. So these two statements, that H sets a limit to all and C sets a limit to all, these are the special features of H cross and C. In other words, there is a universal bound or universality on H cross and C because they apply to all objects. They apply to all objects without any favor or bias. It is a natural limit or a natural bound that is set by nature, and we have nothing to do here. We have no role in these choices. Now, in particle physics, it is advantageous as well as traditional to take C equal to 1 as well as to take H cross equal to 1. Now that makes equations of particle physics simpler. The idea is as follows. Suppose we know only to measure lengths in millimeter, and suppose that we are asked to measure lengths of the books stored in the library. To make the records of measurement easy and convenient, we can set 10 millimeter equal to 1 unit, that is 1 centimeter, and then measuring in centimeter or expressing the results in centimeter would be an easy task. But here we are going a step further for further simplification and at the same time maintaining rigor and ensuring error-free calculation, because here the entire C and the entire H cross is set to unity. Now C is 3 into 10 raised to the power 8 meter per second. In its entirety it is put 1. It is not that C is taken to be 1 meter per second or something like that. In its entirety we take C equal to 1, and instead of H cross, which is 1.055, that is 1.06 into 10 raised to the power minus 34 joule second, in its entirety we take it to be 1. Now the question that one might ask is, why not other choices? There are many other options. Some options may be like, what if we take MP, that is mass of a proton mass, which is actually 1.67 into 10 raised to the power minus 27 kg or 938 MeV by c square, to be set equal to 1. This is not a good choice because there is no universality attached to it. Proton happens to be one of the several particles. So there is no universality that is associated with this mass. Now, electronic charge, which is 1.610 raised to the power minus 19 coulombs with a negative sign, is a fundamental constant. But this is also not a good choice because there are positive charges, negative charges, and as well as there are certain particles which are neutral. In other words, in a nutshell, we can say that all objects do not interact in the same way. They do not exhibit the same kind of interactions, and therefore they are not good choices. we can think of the universal constant of gravitation, that is G. The value of G is given over there, and what if we take G equal to 1? Now actually, G does not come into the equations of particle physics. Particles are too light to feel or experience in a significant way the gravitational force between themselves. And therefore, since gravitational force is negligible, it has nothing great to do or influence the particles. There is no benefit in choosing G equal to 1 in particle physics. Actually, G has no role in particle physics. Therefore, we can leave it free. In particle physics, as we have mentioned just now, C is set equal to 1 and H cross is set equal to 1, and these are called natural units. This is called natural unit. This choice is called natural unit, and let us now discuss certain implications of this choice. Let us first start with C equal to 1. Now the value of C is 3 into 10 to the power 8 meter per second, which we set to be equal to 1. Now if this is equal to 1, then we can multiply the second here, and therefore we end up with this result: 3 into 10 to the power 8 meter equal to 1 second. Now this is length, meter is length, and second implies time. Now this means, this choice actually means we can measure time in units of length, and we can also measure length in units of time, and therefore we can write in this way. Now, do we lose any information if we write C equal to 1? Actually not. Let us elaborate this a bit. Suppose speed of an object is 10 to the power 8 meter per second, and we can multiply the numerator and the denominator both by C to get this expression, in which the C in the denominator is written explicitly in an expanded form, and then simplification gives us this 10 to the power 8, 10 to the power 8 cancels, and we end up with 1/3 C. So this result we get, which in natural unit, if we put C equal to 1, becomes simply 1/3, a dimensionless number. So velocity is 1/3. So this is what we get in natural unit. Now let us reconstruct the original velocity. V equal to 10 to the power 8 meter per second. If we say that, let us take another problem, similar problem. Suppose we say that speed is 0.25. So V is 0.25. This means this can be written as V equal to 0.25 into 1. Now here two things are important. One is, what is this 0.25? 0.25 represents speed, and we have set, to get it, we have earlier set C equal to 1 somewhere, C equal to 1, and that C occurs in the numerator. So we can write it as 0.25 into 1, and instead of 1, since C equal to 1, you get rid of or remove 1 and put C. And then we now go back to the SI system to put the value of C and end up with this result. So this is how we can reconstruct the velocity just from a number. The relation E equal to mc square becomes E equal to m if we put C equal to 1, and another relation of specialty or relativity is E square equal to p square c square plus m0 square c to the power 4, m0 being the rest mass. Now if you put P is the momentum and E is energy. Now if you put C equal to 1, that is in natural units, then this relation becomes a simpler one as written here. And it is evident that the dimension of E and dimension of P means momentum, are same. So if you combine these two results, we end up with this relation. E, P and M, they all have same dimension. Now let us go to H cross equal to 1. Setting H cross equal to 1. This means we have H cross is H by 2 pi. So we put the value of H and divide it by 2 pi to end up with this result. And let us put it equal to 1. So we have this part. And this is written over here, 1.06 10 to the power minus 34 joule equal to 1 second inverse. This second goes to that side, therefore it is inverse of second. And here on this side we have joule. This means a look at this relation suggests that we can measure energy as second inverse. So energy is second inverse, or in other words, second or time is energy inverse. So we can combine all the results. A little while ago we got this result, E equal to P equal to M, and now we have E equal to T inverse, so we write E equal to T inverse, and earlier we got L is equal to T because we put C equal to 1, and therefore we get this relation. Now here one thing should be very importantly mentioned, that the unit of energy is taken as GeV. So this means M can be expressed, this means M can be expressed in terms of E. E is GeV, so M is some GeV, and therefore we can ask the question, 1 kg is how many GeV or how much GeV? And the invert question, 1 GeV is how much kg? Again, E and L are connected. E and L inverse are connected. E and L are connected in this way, where E is equal to L inverse, or L is E inverse. That is, L can be expressed as energy inverse. Energy is in GeV, so L can be written as GeV inverse. Which means we can ask the question, 1 meter, meter being length, unit of length, 1 meter is how many GeV inverse? Or in other words, 1 GeV inverse is how many meters? Again, E and T are connected through this equation, E equal to T inverse. This means we can ask similarly the question, 1 second, second being the unit of time, 1 second is what amount of GeV inverse, or 1 GeV inverse is how many seconds. Now these things will be addressed right now. So let us re-emphasize that unit of energy is taken as GeV, where G is 10 raised to the power 9. So 1 GeV is 10 to the power 9 EV, and 1 EV is equal to 1.6 10 to the power minus 19 joules. So we have this relation, and we can simplify to get this relation, where kilogram meter square second to the power minus 2 comes if we break joule into force into distance. This part is force and this is distance. So 1 GeV is this much in SI system. We are in SI system up to this. Now let us divide 1 GeV by C square. So that means we're dividing this quantity by 3 into 10 to the power 8 meter second inverse square, which simple calculation yields this one, this relation. Therefore, we can multiply c square here and we get this relation. 1 GeV is this much into c square. Now this much was done in SI system, and now in natural unit c is 1, and therefore we can switch it off. So c square is 1, c is 1, so c square is also 1, and therefore we end up with this relation. So the answer to 1 GeV is how much kg is obtained here. And similarly, the inverse relation, 1 kg is how much GeV can be obtained from here, and the amount is 5.610 raised to the power 26 GeV. So these are conversion relations between energy and mass. Let us consider next the product of the two fundamental constants h cross and c, which are extremely important constants as we described a little while back. Now put the value of h cross, which is this one. Here we have taken 1.06, actually it is 1.055, approximated value is put, and that is multiplied by c, which is 3 into 10 to the power 8 meter per second. This is SI, in SI units we are doing, and we know that 1 EV is 1.6 into 10 to the power minus 19 joules, which means 1 joule is 1 by this factor EV. And if you put it here, we end up with this relation. Instead of joule, we have EV here. The second and second cancel out, and we have a meter here. So it is, so H cross C is expressed in this way in terms of EV into meter, and we simplify it. Proper calculation gives us this relation, 1.98 into 10 to the power minus 7 EV into meter, and we can write it judiciously. We are trying to bring in to the picture GeV, which is 10 to the power 9 EV. We are trying to bring Fermi into the picture, so we have to have a 10 to the power minus 15 here. So these groups are introduced and properly adjusted, and therefore we get 0.198. So the final result which we got easily is H cross C is equal to 0.198 GeV into Fermi. If we took 1.055 and put it here instead of 1.06, we would have obtained this result, which is 0.197 GeV into Fermi. Let us use this result and proceed. So H cross C is 0.197 GeV into Fermi, or we can also take 0.198. Now this is in SI unit. In natural unit, we have to put H cross 1 C1. So this side, left side becomes 1. The right side is as it is. Now bring GeV, pull it down here. So we have 1 GeV inverse, and that is equal to 0.197 Fermi. And we can write Fermi in terms of meter to end up with this result. So we have answered the question that 1 GeV inverse is how many meters, that we have answered. And the invert question, that 1 meter is how much GeV inverse, that is obtained here from this one. So this is the answer. This is a conversion factor. These two relations comprise of the conversion factor between GeV inverse, that is energy inverse, and meter, that is length. Let us recall this relation once again. H cross C is equal to 0.198 or 7 GeV into Fermi. This result is in SI unit. And now let us, earlier we used H cross 1 C1. Now to bring time into the picture, here time is hidden in c. C is velocity, velocity is length by time, so time is included here, and we are now trying to bring time explicitly. So to drag it out, let us do away with h cross by putting h cross equal to 1, but keep c, and let us expand c and write 3 into 10 to the power 8 meter per second. The other things remaining same. So we have, therefore, in the next step, as per natural unit, we will write h cross 1. So we have this part 3 into 10 to the power 8. Meter and meter will cancel out. So we are left with 1 by second. On this side 0.197 and 10 to the power minus 15 into GeV. Now pull it down here. GeV can be taken to this side, and say 1 by second can be taken to that side. So it becomes second here, and GeV coming to left side becomes GeV inverse. So we have this relation, which on simplification gives us 1 GeV inverse equal to this much seconds. And the invert relation follows from here: 1 second 1.5 to 10 to the power 24 GeV inverse. So we have been able to address this question: how much GeV inverse is 1 second, or how many seconds are there in 1 GeV inverse. Let us now make a gist of what we did. Natural unit was described in detail, and natural unit means putting c equal to 1 and h cross equal to 1. This is done in particle physics. The conversion factors between SI system and the natural units have been done in detail, have been proved, and they are written over here. And one should also memorize rather this relation, which is extremely important one, which is h cross c equal to 0.197 or 8 GeV Fermi. So we are at the end of this lecture, and in this lecture we came across certain celebrated scientists, namely the Broglie, Einstein, Heisenberg, Max Planck, and Dirac. In the next lecture, which will be named P2b, I'll discuss Planck units and some other problems. Let me share an anecdote relating to Einstein with you all. Clark, an American international lawyer and author of the book, a famous book, World Peace Through World Law, was present with Einstein in a conference in Princeton, New Jersey in 1946 after World War II ended with Japan being devastated by atomic bombs. Clark asked Einstein, why was it that human mind could discover the atom but failed to discover ways to keep atom from destroying humans? Einstein replied promptly, that is simple, my friend. It is because politics is more difficult than physics. In view of this, let me state that the choice is yours. Thank you.